This is the Edexcel Paper 3 higher tier calculator paper from November 2023. Question 1. Write 468,000 in standard form. So to put a number into standard form, we need to write a number between 1 and 10, which is going to be 4.68 times 10 to a power. So how many times do we have to multiply 4.68 by 10 to get 468,000? It will be 5 times, and we can check that on the calculator. If we write 4.68 times 10 to the power of 5, we should get 468,000. Part B, write 5.037 times 10 to the power of negative 4 as an ordinary number. So we need to take it out of standard form this time. That's 5.037 divided by 10 4 times. So that would be 0.0005037. And again, we can check it on the calculator. If I type in 0.0005037, I get 5.037 times 10 to the power of negative 4. Question 2, here is a bias spinner. The table shows the probabilities that when the spinner is spun, it will land on A, on B, on C, and on D. Luca will spin the spinner 200 times, work out an estimate for the number of times it lands on A. So 0.4 is the probability it lands on A. We're doing it 200 times, so it's 0.4 times 200. You could also think of this as 0.4 is 40%. So it's going to land on A 40% of the time, 40% of 200. Either one of those, 0.4 times 200 is 80. So it's 80 times. Question 3. Seeger works at a weather station. The table gives information about the temperature, T degrees Celsius, at midday for each of 50 cities in the UK on Tuesday. Calculate an estimate for the mean temperature. So we've got 50 cities. We don't know the exact temperature at each city, so we're estimating. And to estimate, we're going to use the midpoint. So there's 2 cities between 10 and 15. We're going to say they've both got a temperature of 12.5. We've got 8 cities. For temperature, we're estimating of 17.5. 13 at 22.5. 21 at 27.5. And 6 at 32.5 degrees. So we need to add them all up. And we can do that quickly by multiplying. So 2 cities with a temperature of 12.5. That's 2 12.5s. That's 25 degrees. 8 17.5s. Adds up to 140. 13 22.5s. Makes 292.5. 21 27.5s. Is 577.5, and 6 32.5s makes 195. So we want to add them all up, so we're going to add down here. So it's 25, 140, 292.5, 577.5, and 195. So in total, they add up to 1,230. So that's all of the temperatures added together now, 1,230. There are 50 cities, so we're adding them all up and dividing by how many? And that gives us 24.6. Our estimate for the mean temperature is 24.6 degrees Celsius. Seja says the median temperature is 22.5 because 22.5 is the middle number in the middle group. Is Seja correct? So when we're looking for the median temperature, we're looking for the middle number. And the middle number of 50 cities, if we have 50 cities, we can split them into two 25s. So we're going to count up to 25 here. So 2 and then 8 makes 10. And then 13 makes 23. So the median, the 25th and the 26th number, have to be in the 25 to 30 group. So we've only got 23 cities with a temperature of less than 25 degrees. So the median has got to be bigger than 25 degrees. It's got to be in the 25 to 30 group. So the median must be in the group (25 to 30). So is Seja correct? No, Seja is not correct. Question 4. Jenna is asked to show the inequality -3 to 4, and it can't include -3 and it can include 4 on the number line. Here's their answer. Write down 2 mistakes Jenna has made. So we should have a circle at -3. So we should have a circle at -3. We don't. We have it at -2. And then secondly, because it can include 4, the circle at 4 should be coloured in. So it should have a coloured in circle at 4 to show that it can equal 4. So the circle at 4 should be coloured in or should be shaded. Part B, work out the greatest integer that satisfies the inequality. So the biggest thing y could be that makes this true. So if we plus 7 to both sides, 5y is less than 23, and divide both sides by 5, and 23 over 5 is 4.6. So y has to be less than 4.6. What's the greatest integer? Integer means a whole number. What's the greatest integer it can be? That's 4. It has to be less than 4.6, so the biggest whole number is 4. Question 5. Ali buys packs of balloons and boxes of pencils. 30 balloons in each pack. There are 24 pencils in each box. Ali buys exactly the same amount, the same number of balloons and pencils. Work out how many packs of balloons and how many boxes of pencils she could have bought. You must show your working. So here we're working out a common multiple of 30 and 24. We could write them as their prime factors and work out the lowest common multiple that way. Or we could just write their times tables out. So 30, 60, 90, 120, 150, 180, and so on. And 24, 48, 72, 96, 120, and so on. And we can see that 120 is in both the times tables. It's 4 lots of 30. The fourth one, 1, 2, 3, 4, and it's 5 lots of 24. So Ali could have bought 4 packs of balloons and 5 boxes of pencils. We could also double this and get 240. So we could have got 8 and 10 or 12 and 15. You can multiply it up how many times you want. But for every 4 packs of balloons, we're going to have 5 boxes of pencils. Question 6. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? This is an inverse proportion question. If we do 30 times 4 and get 120, that's how many hours it would take one machine. So 120 hours for one machine. So then we're just going to divide by 6, 120 machine hours of work. So we need 120 of hours of work done. We're going to divide that by 6. So that will be 20. It'll be 20 machines. So 20 machines working for 6 hours means we get 120 of hours of work done. Question 7. Riley travelled by car and by aeroplane. He travelled 143 miles by car at an average speed of 55 miles per hour. Riley then travelled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total travelling time. So we know speed is equal to distance divided by time. If we want to find time, we multiply by time and divide by speed. So time is distance divided by speed. So in the car, the distance was 143 and the speed was 55 miles per hour. So 143 divided by 55 is 2.6. So that's 2.6 hours. If we want that in hours and minutes, we can just press the time button and we find out it's 2 hours and 36 minutes. So 2 hours and 36 minutes. We could have also done 0.6 times 60, which would have told us that 0.6 hours is 36 minutes. And then we just need to add them together. So the total time, 2 hours 36, and we've got 5 hours 20. So 5 hours 20 minutes plus 2 hours 36 minutes makes 7 hours and 56 minutes. Question 8. The diagram shows a solid cube placed on a horizontal table. The pressure on the table is 3.5 newtons per centimetre squared, and pressure is force over area, and the force exerted by the cube on the table is 504 newtons. So we've got the pressure and the force, so we can work out the area of the face that's flat on the table. So let's do that. Pressure equals force over area. So 3.5 equals 504 over area times by the area. So 3.5 times the area equals 504. So the area is 504 divided by 3.5, which is 144 centimetres squared. So that's the area of the base. The question says, show the total surface area of the cube is less than 900 centimetres squared. So it's got 6 faces. It's a cube, so they're all equal. So it's just 6 times 144. And that is 864 centimetres squared. So it is less than 900. 864 is less than 900. Question 9. The line L is shown on the grid. Find an equation for L. So we write the equation of a straight line in the form y equals mx plus c, where m is the gradient. So for every one it goes across, how much does it go up or down? It goes down 2. So it goes across 1, down 2. So the gradient is -2. C is the y-intercept. That's where it crosses the y-axis. And that is at 3. So the equation of the line, we change m into -2, we change c into 3. So y equals -2x plus 3. Question 10. Make m the subject of k equals p plus 2m over 5. So we need to get m by itself. We want to take p away from both sides. So that will give us k minus p equals 2m divided by 5. Then we need to multiply both sides by 5 to get 2m by itself. So we'll have 5 times k minus p is equal to 2m. And then to get m by itself, to get rid of the times by 2, we divide by 2. So we half both sides. So m is going to be 5 times k minus p all over 2. We could expand the brackets, but we don't have to. So I'm going to leave it like this. Question 11. The floor plan of a house is drawn using a scale of 1 to 50. On the plan, a room in the house has a floor area of 48 centimeters squared. Work out the real area of the floor of this room. Give your answer in meters squared. So we've got a few things going on here. We've got a scale factor of 1 to 50, but that's going to be a scale factor for length. So the scale factor for area is scale factor squared. So it's going to be 1 to 50 squared. 1 squared is 1. 50 squared is 2,500. So the scale factor for area is 1 to 2,500. We've also got centimeters squared and meters squared. So we need to be able to convert between them. So if we have a 1 meter square, a square, 1 meter by 1 meter, that's the same as 100 centimeters by 100 centimeters. So how many centimeters squared is that? 100 times 100, that's 10,000. So we've got 48 centimeters squared. We need to times it by the scale factor. 48 times 2,500. 48 times 2,500 is 120,000. So that's in centimeters squared. So it's 120,000 centimeters squared. We need to change that into meters squared. So divide by 10,000. Because each 1 meter squared is 10,000 centimeters squared. We get 12. So 120,000 divided by 10,000. So 12 meters squared. Question 12. The diagram shows a shaded sector, POQ, of a circle with center O and radius 6.2 centimeters. The area of the shaded sector is 82.6 centimeters squared. Calculate the size of the angle X. So we've got part of a circle. So the area of a circle is pi r squared. And we've got a fraction of that circle. So we've got x degrees out of 360 of pi times the radius squared. And we know that that is equal to, so our sector area is equal to 82.6. So x over 360 times pi times the radius squared is equal to 82.6. So we just need to solve for x. So pi times 6.2 squared, that's the area of the circle. If we divide both sides by that, so 82.6 divided by the area of the whole circle, 0.684. So x over 360 must be 0.6839 and so on. And then to get x by itself, multiply by 360. So this is like how much of the circle we have, times it by 360. X is 246 degrees to 3 significant figures. Question 13. Alan grew 80 plants of the same type outside. The cumulative frequency graph shows information about the heights in centimeters of these plants. Part A, one of the plants is chosen at random. Find an estimate for the probability that this plant will have a height greater than 90 centimeters. So 90 centimeters on the graph. So we've got 10 little boxes for 25 centimeters. So each little box must be 2.5 centimeters. So 90 is here. So let's go up to our line and along and read off what we get. So at 90 centimeters, we're at 74. So 74 plants have got a height less than 90. How many is greater than 90? So what's the gap? There are 80 in total, 80 plants in total. So there are 6 with a height greater than 90 out of 80 in total. So it's a probability 6 out of 80 have a height of greater than 90 centimeters. Part B, use the graph to find an estimate for the median height. So there are 80 plants. The median's the middle number, the middle plant. So that's going to be 40. So from 40 along to our line and down. And we'll read off the graph. So each little box is 2.5 centimeters. So that is 60. The median is 60 centimeters. Half of the plants have a height less than 60 centimeters. Part C, use the graph to find an estimate for the interquartile range. So we're going to split our plants into quarters now. And a quarter of the plants, that will be 20 of the plants. So we go from 20 to our line and down. And we'll read off that number, which is 40 centimeters. For 3/4 of the plants, 3/4 of 80 is 60. So 60, and that is 75 centimeters. So 1/4 of the plants have a height less than 40. 1/4 of the plants have a height greater than 75. So the interquartile range is 75. Take away 40. That's 35 centimeters. Alan also grew plants of the same type inside. The interquartile range of the plants inside was 30 centimeters. Give one comparison between the distribution of the heights of plants grown inside with the distribution of the plants grown outside. So we can compare the interquartile ranges. We need to give our answer in context. That means we need to refer to the plants or the height, and it's less inside. So the interquartile range of heights of the plants inside is lower. And that is our comparison. Question 14. Here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term. We've got 5, then 11, then 21, then 35. So the first difference between 5 and 11 is 6. 11 to 21 is 10. And 21 to 34 is 14. The second difference between 6 and 10 is 4. And 10 and 14 is 4. In a quadratic sequence, the second difference is always the same. And then I've got this as 2a. So in a quadratic sequence, an squared plus bn plus c. The second difference is always 2a. The difference between the first 2 terms is always 3a plus a b. And the first term is always a plus b plus c. So if 2 a's are equal to 4, a must be 2. If 3a plus b equals 6, and a is 2, 3 2's make 6. 6 plus b equals 6. B must be 0. And if a plus b plus c equals 5, that means 2 plus nothing plus c is 5. C must be 3. 2 plus 3 makes 5. So our sequence is 2n squared plus no n's plus 3. So 2n squared plus 3. We can check our answer. So if we change n into 1, we should get the first term. So 2 times 1 squared plus 3 should give us 5. If we change n to 2, we should get 11, the second term. If we change n to 3, we should get 21, the third term. And so on. So the 1, 2, 3, 4, 5th term is 53. And we can see we get that. So 2n squared plus 3. Question 15. The diagram shows triangle ABC, the big triangle, and triangle AED, the one inside it, show that triangle ABC and triangle AED are similar. If 2 shapes are similar, one is the enlargement of the other one. So they make the same shape, it's just that one is an enlargement of the other one. So if we had 2, 3, 4 here, and the scale factor was 3, if it was 3 times as big, you'd multiply each of the lengths by 3 to get the lengths of the bigger shape. So it's the same shape, just enlarged. It doesn't quite look like they're similar shapes, and that's because the longest length, well, they both share this angle A, but the longest length of the small triangle is the 32, and the longest length of the bigger one is A to C. So those two go together. So let's try and draw this. So A, I'm going to draw E here and D here. So AED, so A to E is 21.6 and A to D is 32. And then on the enlarged shape, we've got angle A here again, and we've got C here and B up here. So 32 and 22 add up to 54. And 21.6 and 58.4 add up to 80. So A to C is 80, and A to C goes with A to D. So they should have the same scale factor to get from 32 to 80. 80 divided by 32 is 2.5. So 80 divided by 32 is 2.5. So it's 2.5 times as big. And then we should get the same scale factor for the other two lengths. So 21.6 times 2.5 gets 54. So 54 divided by 21.6 is also 2.5. So we times by 2.5. They've got the same scale factor. That means it's a similar shape. So the same scale factor and A is common. Therefore, similar shapes. Question 16. Zia has to set a 4-digit security passcode on her phone. Each digit of the passcode is a number from 1 to 9. She can use each number more than once. Zia tells her friend, Amber, that the first digit is a cube number. The first digit is a cube number. So it can either be 1 times 1 times 1 is 1, or 8, 2 times 2 times 2 is 8, and anything bigger is going to be above 9. The second digit is prime. So 2, 3, not 4, 5, not 6, 7, and not 8, and not 9 are prime numbers. The third digit is greater than 6, so it can be 7, 8, or 9. And the fourth digit is odd, so 1, 3, 5, 7, or 9. The diagram shows one possible 4-digit passcode, 1383. Amber is going to have one attempt at guessing Zia's passcode. Work out the probability that Amber guesses Zia's passcode on the first attempt. So we need to know how many possible passcodes there are. So there's 2 options for the first number, and then 4, and then 3, and then 5. So the number of possible options, the number of combinations is 2 for the first one, then 4 for the second one, 3 for the third digit, and then 5 for the last one. So 2 times 4 times 3 times 5, that's 120. So the probability Amber guesses it at the first attempt is 1 out of 120. Question 17. Write x squared minus 8x plus 3 in the form x minus a squared minus b, where a and b are integers. This is called completing the square. We're going to take the 8 and half it, which will get us to a 4. So x minus 4 squared. We're going to take away the 4 squared, which is 16. And we've still got the plus 3 on the end. So if we expanded x minus 4 times x minus 4, we'd get x squared minus 8x plus 16. So we take away the 16, which means that this part is identical to x squared minus 8x, and then we've still got the plus 3 on the end. And then to simplify it, we've got x minus 4 squared, negative 16 plus 3 is negative 13. Hence, write down the coordinates of the turning point. So the turning point is where the bracket is equal to 0. So that's when x is 4. So the turning point is when x is 4. The bracket is equal to 0. 4 minus 4 is 0. What's left? Negative 13. And part B, solve. We've got a quadratic to solve. We can use the quadratic formula. And the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this question, a is 7, b is 8, and c is negative 5. So 7, 8, negative 5. So let's substitute them in. So we're going to get minus 8 plus or minus the square root of 8 squared minus 4 times 7 times negative 5 all over 2 7s. And then let's just type that into the calculator. We do it twice, once with a plus and once with a minus. So I'm typing it in exactly how it looks, apart from I've only put the plus. So I've got to 3 significant figures, 0.449. And the second answer, so just changing that plus into a minus, and we get negative 1.59. So we've got 0.449 and negative 1.59. Alex has to find the solutions of the quadratic equation 3k squared plus 10k minus 8 equals 0. Here is his working and answer. What mistake has Alex made? So we can see that Alex's first bracket was 3k minus 2. And then the answer given is k equals 2. But if k is 2, that doesn't make this bracket equal to 0. So if 3k minus 2 equals 0, if we add 2 to both sides and then divide by 3, k should be 2/3. So k equals 2 does not make this bracket equal to 0, so it's not the solution. So for the bracket, 3k minus 2 to equal 0, k should be 2/3. Question 18. Enlarge triangle P by scale factor minus 1.5 with centre of enlargement -2, -1. And label your image Q. So the scale factor is minus 1.5. So to go from our centre of enlargement to this green point here, we go back 1, 2, 3, 4, and up 2. So at the moment, to get from the centre of enlargement to the green point, it's a movement of -4, 2. If we times that by minus 1.5, 4 negative times a negative is positive. 4 times 1.5 is 6. And 2 minus 1.5 is -3. So that would be at 6 forwards and down 3 now. To get to this corner, we're going back 6, up 2 at the moment. times it by minus 1.5, and that will be 9, negative 3. So we're going 9 to the right and 3 down. And for this point up here, we're going back 6, up 2, 4, 6. Back 6, up 6. So if it's negative 6, negative 6 at the moment. No, it's not. Negative 6, 6 at the moment. Back 6, up 6. Times it by minus 1.5. That gets us to 9, negative 9. So 9 right and then 9 down. So 9 to the right and then 9 down will get us down to that point. I'm going to join them up. And then we can check that they all line up. So if we draw from our light blue point to our other light blue point, it goes through the center of enlargement. Dark blue to dark blue, through the center of enlargement. And green to green, through the center of enlargement. So we have to label that Q. Triangle P is transformed by a combined transformation for rotation 90 degrees anti-clockwise about the origin, followed by a translation to give triangle R. Exactly one vertex of P is invariant under the combined transformation. Find one possible column vector for the translation. So we're going to take triangle P, rotate it 90 degrees anti-clockwise. So if we rotate P 90 degrees anti-clockwise about the origin, so that we hold the tracing paper at the center. So you can use tracing paper to do this transformation, but to get to the green point, we are 6 left, 1 up at the moment. So if we rotated that 90 degrees, that would be 6 down, 1 to the left. And then 8, 1, 8, 1, and 8, 5 will be 8, 5. So our rotation of 90 degrees gets us to here, and let's just color in these corners just so we know which one's which. Now we want one of these points to be invariant, so that means get back to where it started. So if we want the green point to be invariant, we need to go back 1, 2, 3, 4, 5, and then up 6, 7. So if we go back 5, up 7, the green point will be invariant. So if we go back 5 and up 7, the green point will be invariant. For our dark blue, we would have to go back 7 and then up 9. Or for our light blue point to be invariant, we would have to go back 3 and then up 13. So either of those, so we get the point back to where it started. Question 19. The diagram shows a frustum of a cone. The frustum is made by removing a cone with height 10 centimeters from a solid cone with height 15 centimeters and base diameter 25 centimeters. So there's a cone with a height of 10 centimeters that has been removed. So we have two similar cones. We have a big one with a diameter of 24 and a height of 15. And the small one that's been removed had a height of 10. So the scale factor for lengths is to go from the big one to the small one, we times by 2/3. So we can work out the diameter of the small cone. 2/3 of 24 is 16 centimeters. So 24 times 2/3 is 16. Diameter of the small cone. The solid S is made from removing F from a solid hemisphere, so half a sphere. So that's the bit that's left has been removed from a sphere as shown in the diagram. The hemisphere also has a diameter of 24. Calculate the volume of S. So we've got to calculate the volume of the hemisphere. So that'd be half a sphere will be 2/3 pi r cubed. So volume of hemisphere, 2/3 of pi r cubed, and r is half the diameter, so 12. So 2/3 of pi times 12 cubed. So that's the volume of the hemisphere. 2/3 of pi times 12 cubed. So 1,152 pi centimeters cubed. So that is our volume of our hemisphere. Now we need to work out the volume of the frustum. So it's going to be the big cone, take away the small cone. So the volume of the cone is 1/3 pi r squared h. So volume of, let's do the big cone, 1/3 times pi r squared h. And for the big cone, the radius is 12 and the height is 15. So it's 1/3 of pi times 12 squared times 15. Again, just type that into the calculator. I'll store my first answer as A. And then 1/3 times pi times 12 squared times 15 is 720 pi. Centimeters cubed again. And for the small cone, it's again 1/3 times pi times the radius. So half the diameter, so 8 now. 8 squared times the height. And of the small cone has got a height of 10. So let's store as B, 720 pi. And then we've got 1/3 times pi times 8 squared times 10. So 640/3 pi. And again, centimeters cubed. So the frustum is the volume of the big cone. Take away the volume of the small cone. The volume of the frustum is 720 pi. Take away 640/3 pi. So it's the one we saved as B, take away our last answer, and that gets us to 1,520/3 pi. So we want the volume of the solid S, which is the volume of the sphere or the hemisphere, which was 1152 pi, take away the frustum, so it's the one we saved as A, take away our last answer. So we have an answer in terms of pi or as a decimal. What do we want to give our answer as? 3 significant figures. So that's 2030. 2030 centimeters cubed. Question 20. The turning point on the graph of y equals g of x has coordinates -3, 6. Write down the coordinates of the turning point on the graph y equals g of x minus 7. So when we have a change inside the bracket, it changes the x. And when it says -7 inside the bracket, we do the opposite. So we're plussing 7 to the x coordinate. It's going to be a move of 7 to the right. -3 plus 7 is 4. So the turning point will be at 4, 6. It's 7 spaces to the right. The graph of y equals f of x is shown on the grid. On the grid, sketch the graph of y equals f of -x plus 3. So we've got 2 things to change here, 2 transformations. So f of -x means all the positive x's become negative. All the negative x's become positive. So this point here, if it was just y equals f of minus x, a -2 would become a +2. A -5 would become a +5. A +1 would become a -1. So the graph would take the same shape. The +2 becomes -2. -6 becomes +6. And the graph would look like this. So that is a graph of y equals f of minus x. But we also want to add 3. So that means add 3 to all the y coordinates. So I'm going to take my graph. Instead of having a turning point at 3, it's going to move up 3 spaces. So 1, 2, 3. So it's going to move up to 6. So if you take any of the points, so take this point at -6, -7. The x coordinate becomes positive. So it becomes +6. And we're going to add 3 to the y. So it becomes +6, -4. So we're going to do that transformation, add 3 to all the y's. And multiply the x coordinates by -1. Question 21. A, B, C, and D are points on the circumference of a circle, centre O. A, D, E, and B, C, E are straight lines. Work out the size of angle BDC. B to D to C. So this angle here. Write down any circle theorems that you use. So what circle theorems can we use? So angles in the same segment. So if we've got a straight line here. So a chord. The angles that come from that chord in the same segment are equal. So this angle is 35 degrees as well. Angles in the same segment are equal. So I'm going to write down the circle theorem I'm using. Angles in the same segment are equal. I've got a diameter here. So A to C is the diameter. Any angle in a semicircle, the angle that comes from the diameter, makes a 90-degree angle. So I'll say angle in a diameter is 90 degrees. And then because we've got a straight line, ADE is a straight line, that means we must also have a right angle on the other side. So that's not a circle theorem, but angles in a straight line. Add to 180 degrees. We can use angles in a triangle. Angles in a triangle have to add up to 180 degrees. So 180, take away 90 and take away 28, leaves 62 degrees. And then for triangle ADC, same again. So 180 take away 35 and take away 90 is 55 degrees. Angles in a straight line again. So 62, 55 and something have to add up to 180. So that's 63 degrees. Let's just write angles in a triangle. Add to 180 degrees. Then we'll do angles in a straight line. So that was 63 degrees. Angles on a straight line. And then angles in a triangle again. To finish, that will find x. We've got a triangle BCD. So 180, take away the 35, the 63 and the 55, leaves us with 27 degrees. So x is 27 degrees. Question 22. Ebony makes some bracelets to sell. The materials to make all the bracelets cost £190. Correct the nearest £5. So it's going to be a bounds question. So if it's 190 to the nearest 5, that means we can have a lower bound of 187.5 and an upper bound of 192.5. Ebony sells all the bracelets for a total of 875. Correct the nearest £5 again. So again, 875. The one up is 880. The one down is 870. So the lower bound is 872.5 and the upper bound is 877.5. The total time taken to sell all the bracelets was 72 hours to the nearest hour. So that's between 71.5 hours and 72.5 hours. Ebony uses this method to calculate her hourly rate of pay. The minimum hourly rate for Ebony's age is £8.20. By considering bounds, determining if Ebony's hourly rate was definitely more than £8.20. So we want to calculate the lower bound. So the lower bound is what we want to calculate. And we're going to do that by calculating the smallest possible profit divided by the biggest possible amount of time taken. So the smallest possible profit is going to be the smallest possible revenue, 872.5, take away the biggest possible cost, 192.5, divided by the biggest possible amount of time, 72.5 hours. So we'll just type that into the calculator. and we get £9.38. So, was it definitely more? Yes. Yes, it was. Question 23. Given that 2x squared plus y squared all over 4x squared minus y squared is equal to 43 over 11, where x and y are greater than 0, find in its simplest form the ratio of x to y. So let's just start simplifying this and see where we end up. So if I get rid of the fractions first, so times by 11 and times by 4x squared minus y squared, we'll just see where we get. So I've got 22x squared plus 11y squared equals 43 times 4, which is 172. 172x squared minus 43y squared. Let's get the x's on one side and the y's on the other side. So we'll get 54y squareds equals 150x squareds. And then let's square root both sides. So we're going to have square root 54, which is 3 root 6. So 3 root 6y. Square root 150. 5 root 6. 5 root 6 x. Divide both sides by root 6. We just get 3y equals 5x. So we can change that into a ratio. So the ratio of x to y is 3 to 5. So 5 x's are equal to 3 y's because we've got 3 parts and 5 parts. If we times x by 5, we get 15, and times y by 3, we get 15. So 5 x's equals 3 y's. So the ratio of x to y is 3 to 5. Question 24. The diagram shows a triangular prism with a horizontal rectangular base, ABCD. M is the midpoint of AD. The vertex T is vertically above M. A to B is 14.7. B to C is 3.8. And M to T is 2.3. P is the point on AB, such that A to P to B is 5 to 2. So somewhere around here, and it's 5/7 and 2/7. So we know the whole thing. So 5/7 of 14.7 is 10.5. So let's just do that. So 5/7 of 14.7 is 10.5. So we've got 10.5 and 14.7. Take away 10.5 is 4.2. So we've got 10.5 and 4.2, and that's P in the middle. Calculate the size of the angle between TP, so T to P, and the base ABCD. Give your answer to 1 decimal place. So we have a right angle triangle here. So we know we've got 2.3 as the height. We can work out M to P using Pythagoras. So let's just draw a right angle triangle. So we've got M, A, and P. M to A is 1.9. It's half of 3.8. A to P, we know is 10.5. So we can work out M to P. So 1.9 squared plus 10.5 squared equals M to P squared. So 1.9 squared plus 10.5 squared. That's 113.86. Square root the answer, we get 10.67 centimeters. So now we know M to P, we know T to M, so we can just calculate the angle using SOHCAHTOA. So we've got TMP. We are working out the angle at P. M to P is what we worked out, 10.67. And we know M to T is 2.3. So we have the opposite and we have the adjacent. So it's tan. Tan x is TOA, opposite over adjacent. So x is equal to shift tan 2.3 over 10.67. Shift tan 2.3 over our last answer. And we get 12.2 degrees.